My name is Xin Ying. I am a software developer at Enco, Senior Bahat. Just wondering, can people at the back hear me? Okay? All right, awesome. Great. So today I will be talking about prototyping your next big idea, but essentially this is an introduction to Google Cloud Platform. Just wondering, who here knows about Google Cloud Platform? Do you know what it is? Could you raise it a bit higher? I can't really see. Okay. So I guess you've not used that before. That's fine. Do you know like AWS or Azure, Microsoft Azure? It's quite similar. Okay. So yeah, we'll get to that. Essentially, the question I would like to ask firstly is, what are the common problems to stop you from getting a big idea off the ground? Usually you have an idea that's brewing in the back of your mind and you feel like, oh, I should do this sometime, but you never do. But why? Well, usually it's because you don't have the resources, maybe, or you don't have the time, or maybe you don't know how to get started. So today we'll address the last one, but we'll also sort of address the first two. So to get something started, usually you need, for a developer, for tech business or project to get started, usually you'll need servers, you'll need APIs, things like that. They are readily available if you use Google Cloud Platform. It's a suite of cloud computing services. So there are about 150, and they are provided by Google. So you know those apps that you use on a daily basis, such as YouTube, Gmail, let's say Google Drive. They are deployed to millions of people around the world. And Google Cloud Platform is built on the same backbone. So you can be assured of its reliability. So they offer over 150 services, I counted. And they include website and server hosting. So for example, you could host it on App Engine, Compute Engine, where you spin up virtual machine instances, or Kubernetes if you have containers that you would like to deploy. These are not all. These are just some. And databases, for example, if you have relational databases, you can consider Cloud Spanner, you can consider Cloud SQL, or non-relational, there's Firestore, Bigtable, real-time database, etc., etc. Data analytics, BigQuery is a very famous one. If you've heard of it, it's pretty fast. It queries relational databases really quickly. There's Dataflow, Datafrog, and Spark and Hadoop if you use it in your companies, etc. And AI and machine learning tools, now they have a lot of, they recently launched Google AI Platform, where they offer a lot of models and machine learning tools for that. But that sounds like a lot. Like, where do you get started? So today we will use my project as an example. As you know, DevFest has a bunch of showcases available down below. I'm not sure, have you guys had a chance to check them out yet? Or you just came here and dashed straight for the talks? Yes, okay, I expect so. Well, when you do go down, there are a lot of cool showcases around, so you should definitely have a look. One of them is my project, which we'll be talking about now, and it's basically using weather data to configure IoT devices in a restaurant. So how this works, let's say you're trying to make your restaurant extra special. So it's not just the food, but you're going to put some tech into it. So let's say, what if you have a restaurant that has IoT devices on it? So every day, are people familiar with the term IoT first before we start? No? Do you know what IoT stands for? Somebody could just shout it out if you know it. No? Okay, I'm pretty sure a lot of people do. So Internet of Things essentially are low-powered devices that can connect to the internet and send data that way. So for example, the chair could technically be Internet of Things if you connect it to the internet, and maybe it can detect if people are, let's say for example, if you want to make this place more high-tech, maybe all of your chairs could be Internet of Things if they're connected to sensors to tell, oh, this person is sitting here, that person is sitting there, and then you can have someone in the back end doing data analytics, checking. Okay, so more people like sitting on the left. Why is that? Maybe it's because it's closer to, more talks are held in the morning, which is maybe east is from that side, I'm not sure. I think so. and they like the light from there, and maybe the design of the next hall could be better. So even random things, ordinary things, could be Internet of Things devices. So for restaurant, I'm going to take the example of what if you have an outdoors restaurant. So a restaurant, let's say, by a beautiful sea with lots of chairs and tables and delicious food. So you'll have umbrellas with those chairs and tables, right? Because it's an outdoors restaurant. And sometimes weather conditions are unexpected. And it could be really hot, it could be rainy, etc. So when it's rainy, usually you see like bunches of people dashing forward, trying to open up all the umbrellas at one time. So what if you had an IoT system for it? So you check the weather data, see, okay, it's rainy. So that means my umbrella should be open. It's sunny, my umbrella should be open. But if it's cloudy, I'll close all my umbrellas so that people can sit back and enjoy the view. So that could be one way of how you would use IoT. So we'll break this into 3 steps. We will first gather weather data. That will be through APIs. So usually people expose APIs so that you can get the data from them. Then we'll send it for data processing. So what that means is the weather data itself will be used to, we'll convert that into a bunch of device configurations. What that means is, for example, if the weather today was sunny, then I would take that data, process it, and return, okay, it's sunny, so that means the fan must be on because it's going to be hot. The umbrella needs to be open because I need some shade, and etc., etc. Next, once you process the data, you will then send the configuration to the IoT devices. So you actually have to tell the IoT devices, hey, this is what you should be doing. You should open the fan, you should open the umbrellas, and it would run. So, but of course, since this is a project, and weather usually doesn't change that much during the course of an afternoon. So for the project downstairs, I've actually made a small website, and it would show 3 weathers that you can pick from. You can pick from sunny, cloudy, rainy, and you just click them, and it would send the data to backend, just for the purpose of this project. So in this project, we're getting rid of the weather API. We're not querying from an actual API. And we'll just get the data from the website. Get the data, process it, return the configuration changes, and deploy them to all IoT devices. So step 1 is building a web app. So this is how the web app looks like. So you can see there is, firstly, the first line says what is the current weather, what is the current chosen weather. And there are 3 icons there for 1 button for each of the different weather that's possible. So if you want to change the weather, just click on one of them. Now, an interesting thing to note here is that thing. The word rainy, it actually changes according to what's currently selected weather. So how is that done? You don't have to reload the page or anything. That's because the database is actually, I actually use Firestore for a database. Firebase Firestore is a flexible and scalable NoSQL database, and it also has real-time listeners. What that means is you could have your client applications, let's say your web apps or websites, have a listener listen for any changes to the document values. In Firestore, data is stored as collections and as collections of documents. In this case, this is an example of the document for current weather, where I'm querying for what is the current weather to post on the website. So if anything changes here, if the current weather changes, then you'll update the website immediately. For hosting a website, as I've mentioned before, there are lots of options, App Engine, Compute Engine, now it's Cloud Run even, but one of the easier ones is using Firebase hosting. Because all you need to do is you can download the Firebase command line interface, and all you need to do is run Firebase deploy. There's some configurations, but essentially just Firebase deploy when you're done. It would give you a free domain. It's a very bad domain. It's just like a bunch of random strings, but it does have SSL, which is good. You can also add your own domain names to it. Okay, so what have we covered so far? First, you get the weather data. Instead of using weather API, we are using the website. So people can select what weather they like, and it would send it to somewhere, don't know where yet, that's the black box. It also gets the data from the database, which is Firebase's Firestore. But of course, if you can get the data from the database, you need to be able to put the data first in the first place, right? So how is that done? So that's step 2. We need to create an API where when you call it, you can send it the latest current weather status, and it would update itself automatically. So what it should do, you send it the weather, say it's sunny or rainy or whatever, and it should return, it should first update the database from Firestore, but it should also be able to process and return the configuration change. So for example, weather sunny, the fan should be on, the umbrella should be open, and the menu, which is the third device, which is shown below, the menu is essentially a recommendation menu. So depending on the weather, it will recommend different drinks. So the menu would be set to the recommendation menu for sunny days. Okay, so what are we using here? We're using Cloud Functions. You can use other things, of course, but Cloud Functions is what I prefer because they are very lightweight. All you need to do is give them a function to run. So it's just a function. You don't even have to do any configuration or anything like that. It's a function. And what the Google Cloud Functions would do is they will spin up an instance for you, and it will run that function, and then close the instance if it's not being used. If it is, then you just keep running. So they're serverless, so that means you don't do any server configuration, and they're very scalable. So Google will take care of spinning as many instances as needed to run your functions. They're really, really good for linking services together. So you have something running here and something running there. You don't know how to connect them together, use a Cloud Function. Very easy. And you can trigger them multiple ways. You can trigger them by putting something in a bucket. You can trigger them using pops up, something that won't be really covered today. You can look it up. And you can trigger them via an HTTP endpoint. So pass a function, it will run. Very easy. So in this case, for different weathers, we will have different configurations for different devices. These are the configurations. Essentially, it makes sense, right? If it's sunny, you have the fan on, umbrella open, and the menu is sunny, sort of things. So what you do is you convert that JSON. Weather sunny, it will be converted to another JSON like that. Make sense? Okay. So far, we have the website. It sends, once somebody selects the weather, it will send the weather to Cloud Functions. Then it will process the data, and it will send the data to Firebase to update the database. Then it would also process the data to get the device configurations. So say the umbrella should be open, the fan should be on, etc. But where does it go? You need to actually update the IoT devices, right, with the new configurations. So that's where we connect it to Cloud IoT Core. So step 3, we're going to make the hardware, and we're going to connect it to Cloud IoT Core. For this project, the things that I used are motors and servos. Those are the fun things that spin around and make things interesting. You open an umbrella, etc. I also use a Raspberry Pi, so it's a miniature computer. Some of you would have already played around with it if you joined our Road to DevFest series. Essentially, it's a miniature computer. It is still being used by a lot of schools around UK especially to teach secondary school students how to use computers and how to program them, and also how to build circuits. Because the Raspberry Pi, it has a bunch of pins. You notice the pins over there, the little sharp pointy edges? They actually go to the wire here, the end of the wire of the servos. You can connect them to those pins, and therefore you can control them. So an ordinary servo motor, a really traditionally intelligent device, can actually be made to connect to the cloud indirectly via the Raspberry Pi. So Raspberry Pi, it actually has Wi-Fi and Bluetooth capabilities. So that means you can connect to the cloud, and you can receive changes or configuration data from there, and then update the servos and motors accordingly. So, but how does Cloud Platform talk to the Raspberry Pi? That's where IoT Core comes in. So you receive a configuration change. So IoT Core would send a configuration change. Say the fan needs to be on, it will send it down to, IoT Core actually connects to the Raspberry Pi via MQTT connection. So you have a client application running on a Raspberry Pi. You have a program that's running, keeping it active, and you'll always be listening for new data from the configuration from IoT Core. So if new data comes in, then it would update, it would send data through the pins, it would send it to the motors, and they will move accordingly. For authentication, for those who are curious, you authenticate this via public and private key pairs and JSON Web Token. So you use the private key pair to sign the JSON Web Token, send it to IoT Core. The IoT Core will have the public key. So you can connect them via MQTT or HTTP. MQTT is a lightweight protocol meant for low-power devices. And it's good for if you have higher latency. So how does IoT Core work? It actually does two things. So you can send data and you can receive data. Sending data is important for telemetry. For example, if you have sensors, like water sensors, for example, you put the sensor somewhere and it should send water level data to the cloud so you can process them for data analysis. If you are sending data will go to Cloud PubSub, which is it's actually a messaging system, but we're not covering that today. For today's project, I'm actually using the receive data part. So to receive data, Cloud IoT Core maintains an MQTT connection with the Raspberry Pi, and it will listen for changes, as I mentioned before. And that's how it's done. So it listens for configuration changes and updates itself accordingly. So the fan is supposed to be on, then it will on. You've seen this one before. So and you can play around with it downstairs later. So that's the full project. You have a website. It's normally a weather API where you can get the weather data from. Normally it's a weather API, but just for the project, it's a website. And you send the weather data, if it's sunny or not, you send it down to Cloud Functions where it will process the data. It will update the database so that the website knows what is the current status. But the data or the weather data, so if it's sunny or rainy, whatever, will be processed to get a device configuration, to get is the fan on, is what on, etc. And it will send that data to Cloud IoT Core. Cloud IoT Core maintains MQTT connection with the Raspberry Pi, and therefore it can send data there. Raspberry Pi will listen for it. Okay, fan needs to be on. Okay, this motor, this servo, you should switch on. And that's it. It's actually pretty simple. The best part about this is scalability. If I decide tomorrow that, okay, I'm going to take this to the world, I'm going to slowly build out a business selling this sort of devices to restaurants around the world, I can. Because all these products are built on Google's infrastructure, and they are pretty resilient and powerful. It's scalable. I can have one instance now, and I can have 1,000 instances in the next few minutes. It's pretty impressive. For those who are interested in getting started with Google Cloud Platform, I do have some suggestions for you. Of course, as always, documentation is important, and it's usually well written, so you can start with that. And they have code labs. Code labs are like basically a bunch of instructions, exercises that you can go through. The official Google Cloud blog has a lot of first-hand case studies from companies that have used their products. So if you are considering something for your business, it's usually good to have a look at what other businesses are doing with it. Quick Labs. Oh, I love this. Quick Labs, it's a website. Go to quicklabs.com, and they would actually give you temporary credentials to actual Google Cloud Platform consoles. So you can actually finish the whole code lab exercise using the credentials, and later it would, after an hour or so, it would delete everything for you. So you don't need to worry about not deleting your project and it eating up your billing, your money. If you get started, you do have a free $300 USD credits, but you must finish it within the year. Also, if you do decide to go that route of experimenting yourself with the $300 free credits, please enable billing alerts. So you can be notified whenever you pass a certain limit. Let's say you don't want to pass like $20 per month. Not sure I can do that, but you can set that up. Then you'll receive emails. Google Cloud Platform Podcast is really nice if you want to listen to a podcast. For startups, this is a special thing for DevFest. You can actually apply for, if you're a startup, I believe you have to be less than 5 years old. You can apply for $3,000 USD credits for Cloud and Firebase. You don't have to take a picture of this. I do have the links here. So if you scan that QR code, how to get started with GCP, I provide all the links there, and you can have a look. If you have any feedback about this talk, please fill that out. I would really appreciate it. But that's all from me. Thank you.